Hey guys, and welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about how we can train neural networks on Google's TPUs. So throughout this tutorial here on deep learning and neural networks, we've mainly been working with GPUs. So we're using Google's hardware accelerators to accelerate the training process and the prediction process of our neural networks, both the artificial neural networks and also the convolutional neural networks. So in this video here, I'm going to show you how we can set up the TPU accelerator in Google Colab and how we can actually train our neural networks on Google's TPUs, because it is really useful and very efficient and really fast to train neural networks on the TPUs. But first of all, remember to join the Discord server. I'll link to it down in the description, where we have a small community where we're talking about different kind of stuff within artificial intelligence, deep learning, and neural networks, and also computer vision and stuff like that. And also, if you have some different kind of problems with your projects and your own applications, you can go ask the questions in there, and then the other guys and or myself can answer those questions. Or also, if you want some inspiration for some projects that you're doing on their own, make sure to join that community and come talk with us. So first of all, here we're going to talk about what is a TPU. So first of all, we're going to have this short introduction to what is a TPU and why should we use a TPU, and then later on we're going to go into actual code and see how we can set up TPU in Google Colab, so we can actually use Google's tensor processing units to actually do our training on our neural networks. So a TPU is a tensor processing unit, so it's just a specific hardware accelerator for actually doing tensor operations, or more known as matrix and also vector multiplications. So we have these different kind of matrix processing units inside our TPU here, and this is just really specific hardware to do those matrix and vector operations. So mainly it's multiplication and addition of matrices and vectors. So we both have a CPU, which is more a general purpose computer. So we have our central processing unit. So those that is doing the general purpose stuff, and it's not really specific for doing neural network training and stuff like that. So if we want to train on neural networks on a CPU, it will just take a really long time, and we want to really be able to use it to train convolutional neural networks on images and a really large data set. And then we can also use the GPU, which we have been using throughout this tutorial here, which is also really good. And the GPU more handles the graphical interface of our computer, so it's really good at doing matrix multiplication and rendering of different kind of images and just doing operations on images. So it's mainly also really good for doing matrix multiplications and additions and stuff like that. But it's more general for a graphical rendering, and also just a graphical interface of a computer, where a TPU is really specific hardware which can actually only do matrix multiplications and vector operations and stuff like that. So we can use it for general purpose of things, and we can use it for a graphical interface and stuff like that. It is just a hardware accelerator, is a really specific hardware for a specific task. So we can use TPUs to actually train our neural networks on, and then we can use Google's TPUs, where we're actually just going to train our neural network, pass all the different kind of calculations to the TPUs of Google, and then we will just do all the different kind of calculations with matrices and the vectors from our images that we're going to train our neural network on, and then we just get the results back from the TPUs here. And then we actually have some different kind of parallelism, where we can do and we can actually do parallelism and distribute our training over the different kind of TPUs. So here on this TPU here, we actually have 8 cores, so we can actually pass a batch of images to this TPU here, and then we'll process all of the batches here on the different kind of tensor or the matrix processing unit cores here. So we have 8 of those on this chip here, which is the Google Colab's tensor processing unit. So now we're going to talk about the Google's TPUs in Colab and how it actually works. So we have our virtual machine here that we're running in our own Google Colab notebook, and then we're creating our own neural network. We have our data, and then we want to train our neural network on the Google TPUs. Then we're going to send the network to the host virtual machines in the cloud TPU on Google, and then that virtual machine would actually do all the different kind of distribution of our neural network and the different kind of calculations that we need to do on the tensor processing unit board. And then it will just send all of those calculations to the tensor processing unit here in Google, where we can see do actually have these 8 CPU cores. And then it will send all the calculations to do actual matrix multiplication, addition, vector, different kind of operations on the tensor processing unit board here. and it will do it really fast because this is hardware specific designed to do those calculations. And then when it's done doing those calculations, it will just send it back to the host virtual machine, and then we can actually like get it through our own neural network, or like it will send our neural network and the training process and the training data back to us in the Google Colab notebook. So then we actually like just distribute our training process to the Google Colab's like TPUs, and then it will send the results back to us in our own virtual machine. And then we have actually like trained our neural networks, and we have done the different kind of calculations and operations that we need to do when we're training neural networks on the Google Cloud TPUs, and then it will just send the results back to us. So it's really good for training neural networks, like really large convolutional neural networks, when we have a really huge data set compared to like DPU. So I'll do another video where we're going to compare like the results of the GPU and TPU when we're talking about like the training process of neural networks here in Google Colab. So we're now jumping into Google Colab here, and I'm going to show you like how we can actually like set up the TPU in the Google Colab here and use the TPU hardware accelerator. And then we're going to load in a data set which is already built into the TensorFlow framework, and then we're actually like going to train a neural network and see like how fast it actually like trains on the TPUs of Google. So first of all, here we're going to go up here in the runtime here, and then we need to change the runtime type here to the TPU. So in the previous tutorials, well, as I already said, we have been using the TPU here, or if you specify none here, it will just train on the CPU of the in Google Colab here. But in this case here, we need to choose this TPU here as the hardware accelerator, and then we need to save it here. So now we're actually like chosen that we want to use the TPU here, and now we're just ready to set it up. And then when we have set it up, we can actually just use the different kind of like fit functions and stuff like that, as we already used in the previous tutorials or like previous videos in the tutorial here. And then it will just use the TPU because that is available for the training. So first of all, here we're just going to import TensorFlow here. We're going to import NumPy and the datasets that we're going to use to actually like train on neural network here. So if I run this block of code here, we'll just import the different kind of modules that we need. And then down here, we need to check if the TPU is set as the hardware accelerator, and then we need to get the address of the TPU that we're going to use. So first of all, here we're going to have this assertion here where we're just going to check if we have chosen the TPU as a hardware accelerator. And then we go down here and see that if we have like this address here that we have chosen our TPU as a hardware accelerator, then we're going to get this address here of the TPU from Google here. So we're going to have this os.environment, and then we're going to find the address of the TPU here in the Google Colab, and then we will store that address here of the TPU in this tf master variable here that we then at the end here set equal to the TPU address here, that we can then use later on to actually like initialize the TPU, so we can get like number of TPUs and actually like get a TPU board in the Google Colab cloud, or like in the TPU cloud. So if we run this block of code here, we'll actually like check if our TPU is set as a hardware accelerator, and we can see that we actually like have, because or else we will have this assertion here where it will write out that we're missing the TPU, the do crest at TPU in notebook settings. So we don't get any output here, so we know that we have set the TPU as hardware accelerator, and we have now gotten this TPU address stored in this variable here. So now we can go down and actually like initialize the TPU. So to initialize the TPU, we're going to use this tf.distribute here. So we're going to use this class here from the TensorFlow library. And then we're going to use this cluster resolver here and the TPU cluster resolver here, which we're going to pass the TPU address that we got up here from this block of code here. And this is just like how we can set up the TPU. So this is just like a standard procedure that you have to go through every time you want to set up a TPU here in Google Colab and actually like use Google's TPUs to train on. Then we're going to store it in this resolver here that we can then use to pass on to this function down here, or like these methods here. So that we're going to pass it to this config experimental connector cluster. So to actually like resolver that we like created up here or initialized up here from this distribute class here. So we're going to distribute the training process here to the Google TPU cloud, and then we have this resolver here that we're going to set up and connect to this cluster here in the config of the TensorFlow. And then this is the TPU initialization code, and we need to run this here at the beginning of the code here every time we want to use the TPU. And then we're just going to set this resolver here. So we're going to have this TPU.experimental initialize TPU system, and then we just pass the resolver here. And this is what actually like initializes the TPU system. So we just need to specify and run these lines of code here, and then TensorFlow will take care of the rest under the hood here. And then we're going to print out the number and like all the devices that we get. So we get like the list of all the logical devices, and we want to have the TPU. So we need to specify this TPU keyboard here, and we also get some CPUs because we know from the slides here that we actually like pass it the network to the Google TPU cloud, which actually like runs on some virtual machines which has some TPUs that distributes the training and the different kind of calculations to the actual TPUs of Google. So we both get some GPUs and also some TPUs available here, and then down here we're just going to print out the number of devices that we actually like have, so the number of TPUs that we have available when we have set up this when we have initialized our TPUs here. So first of all, here we're just going to run this block of code here and set up and initialize the TPU. So we can see that we're initializing the TPU system here to this like IP address here with some with this port number here. So we can see that we're actually like connecting to the TPU system of Google Colab. And we can see here that we have finished initializing the TPU system. And here we just get out like all the devices that we have. So we can see that we have this TPU here, and we have a TPU here. And if we go here down to the end here, we can see that we actually like get the TPUs here, and we have now listed all the TPUs that we have available in the Google TPU cloud. And we can see that we have the number of devices here is 8, because we know that we have 8 tensor processing unit cores on each of the boards, as I showed you in the slide. So we have one board, and then we have 8 tensor processing units on each on those boards. So after we have initialized the TPU here, we actually like need to choose a distribution strategy for our hardware accelerator. So the way we're going to distribute the different kind of calculations and operations that we're going to do on the TPU. And then we're going to run the model on multiple TPUs in a data parallel way. So when we're going to specify this distribution strategy here, we can actually like have our data run in parallel when we're going to run our model on the multiple TPUs that we know we have on the board. So in this case, we have 8 tensor processing unit cores on this TPU board in the Google Cloud. And then we're just going to specify the strategy here, where we're going to specify the tf.distribute, and then we're going to set the TPU strategy here to the resolver variable here that we already initialized up earlier in the code. So if we run this block of code here, we will just choose the distribution strategy we want to use. And we can see here that we found a TPU system. We have 8 TPU cores, we have 1 TPU worker, and then we have like a number of TPU cores per worker. So we have 8 TPU cores per worker, as we can see. So we have one board available to actually like do our calculations and operations on. And then we can just see here that we have these different kind of available devices here. So we'll just tell us what like devices we have from 0 to 8, or like from 0 to like 7. And then down here we can actually like create a convolutional neural network and train it on the TPU, so we can see like how fast it actually like trains on the Google Colab's TPUs. So first of all, here we're just going to create this sequential model here, which is just like an arbitrary sequential model here that we're going to actually like do, so we can just show the results of training it on the TPUs. So if you're interested in like how we can create like convolutional neural networks in Google Colab here with Keras and TensorFlow, I've already made a tutorial or like a video about that, so make sure to check that out if you want to know like how we can create a convolutional neural network from scratch, train it on our own dataset, or like a dataset that is already built into TensorFlow or Keras, and then how we can actually like train it and do predictions on data that it hasn't seen before. So make sure to check that tutorial out if you're interested in how we can actually like create neural networks. So we're going to just specify this neural network up here. We have 2 different types here, but we're just going to use the first one up here. So we're going to have this create model here that we can then call later on when we're going to actually like compile a model. And then we can go down here and load the MNIST dataset. So this is just like how we can load in the dataset. So we need to specify the batch size, and if we're going to train use this dataset here for training, because we don't both want a dataset for our training and also like for our testing. We want to have a data set for that as well, where we have data that our neural network hasn't trained on before. So this is just like a function that we're just going to use to actually like get in the data set. So I won't go into details like how this works. And then we can go down here and actually like compile a model. So we're going to like create a model here where we call this function here. So first of all, we need this with strategy.scope here. So we're going to use the strategy, or like the distribution strategy that we specified earlier in the code here. So we actually like can pass this model or this convolutional network here to Google, so we can actually like use their TPUs to do the actual training on a neural network. And then we're going to use this model.compile here. We're just going to compile the neural network that we're going to send to Google. And then we use the optimizer, atom optimizer here, and we're going to specify the loss function. So in this case, we want to use the sparse categorical cross entropy loss function, and we also specify the metrics that we want to get back to see like how good our neural networks performs in like each epoch in our training process. And then we're just going to do a summary here of our model. So if I run the block of codes up here, so we can load in our dataset later on. And then we're going to compile a model here. So we're going to like create a model here where we get this model that we created earlier. We're going to do a summary of it so we can see like the different kind of layers that we have, the number of parameters that we actually have. So we have close to 40 million parameters that we're going to train in our in Google Colab here with our tensor processing unit. So all of these parameters here will be tuned when we're training our neural network, or like our convolutional neural network here on the Google Colab TPUs. And then down here, we're actually like going to train the model on the TPU. So first of all, here we're going to specify batch size, and then we're going to get the train set here and the test set here of the MNIST dataset. So this is handwritten digits that we're going to load in and train our neural network on. So we're actually like able to predict on images where we have a handwritten digits. So we want to see like if this is a 0 or like a 6 or something like that. And then we run this block of code here, we get in the data set, and then we can go down here and actually like specify this fit function here, which will actually like do the training of our convolutional neural network. And when we have specified and set up the TPU, it will actually like use that as default and send the neural network and the training to Google, so we can train on their TPUs. So we're going to specify the number of epochs that we're going to run for, and the steps per epoch and validation steps. So this is like, if you want to know how specific like what these different kind of parameters does, and also like what is going on in the fit function here, make sure to check the tutorials out where I've already went over like how we can create and train convolutional neural networks. So this fit function here is just what the actual like where we're actually like going to train our neural network on. So if I run this block of code here, we're actually like going to send our neural network to the Google's TPUs, and then it will do all the operations on the tensor processing board that we know we have with the 8 TPU cores, and then it will send all the results back to our Google Colab notebook here that we're running here in Google Colab here. So we can see here that we're running through 5 epochs here, and then we have like 300 here, which is the steps per epoch that we're taking. So we're taking 300 steps, we're passing like our batches, like 200 batches through 300 times per epoch. And then we can see here that we get the losses, the sparse categorical accuracy here, and we also get our validation loss and our validation accuracy here for our model, so we can see like how good our model performs during training. And we can see like for each epoch, it only takes 21 seconds for the first one here, and then the rest here only takes 10 seconds per epoch that we're training like 60,000 images on. So we're taking 60,000 images per epoch, we're passing it through the neural network, and it only takes 10 seconds to do the actual training, do all the calculations on the 40 million parameters. Like the 40 million trainable parameters here will be tuned and optimized during each epoch here. So when our neural network is done training here, we can actually like see how good it performs while training, and also like what is the best model. So we can see here that our loss while training here, epoch per epoch, that our loss is actually like decreasing, and we get a really low loss here at the end here after 5 epochs, when we have passed our data through like 300 times per epoch. And then we can actually see here that we get a really low loss, we get a really high accuracy, like really close to 100% accuracy on this data set here that we've been training on the Google's TPUs. And we also get a fairly low validation loss and a really high validation accuracy. So we can see that we're not really overfitting to the data, and we're able to do predictions on data that we haven't trained our convolutional neural network on. So this is like how we can actually like do training on the Google Colab's TPUs, which is really fast. So we can see like how fast it performs. So 10 seconds to run through each epoch and train on 60,000 images. So I'm going to do another video where we're going to compare the performance of CPU, GPU, and TPU, so we can actually like see how good TPUs are compared to like the CPU, and also how good it is compared to the GPU. The GPU is also like fairly fast, but the TPU just outperforms both the GPU and the CPU, and in a massive way, because it's just really so fast when we're using these TPUs here, which is just designed specific for doing those operations here that we have when we're doing like training of neural networks. So we can actually go down here and we can actually like optimize the way the way that we're passing the data to our to the TPUs of the Google here. So when we're going to compile a model here, if we go down here and specify this steps per execution here and set it equal to anything between like 2 and the number of steps per epoch that we have specified, then we can actually like get a way better result and up to 50% faster execution of our neural network and training of our neural network when we specify these steps per execution here. So this is the exact same code here as we had previous here, but we just specified this steps per execution equal to 50. And if we run this block of code here, we can actually like see how fast it is and how much we have actually like optimized it just with this line of code here. Compared to up here where we have 21 seconds in the first epoch, 10 seconds, 10 seconds, 11 seconds, and 11 seconds for the rest of the epochs. And if we go down here and see like how good it performs, so we can see the first epoch here is 15 seconds. So it's a really good improvement when we're passing 60,000 images through our neural network here. And we can see the rest of the epochs here is only taking 5 seconds to run 60,000 images and train 40 million parameters. So it's really fast to use TPUs when we're actually like doing training on really large convolutional neural networks with really large data set. So we can see that we're actually like halving the time. So our neural network training process is actually like twice as fast when we're going to specify these steps per execution. And you can actually like play around with this parameter here and tune it and see if you can get better results by tuning this parameter here. So this is the actual only difference between the previous training process up here and the one down here, and we actually like did twice as we did actually training process twice as fast when we did it with this optimization step here, which is specified in like the Google Colab's TPU documentation and what it does under the hood. So this is just like, so it optimizes the process that it's doing when it's passing the different kind of calculations to the TPUs. So that's pretty much it for this video here, guys. We've been over like how we can set up the TPU in Google Colab here and how we can use the TPU as a hardware accelerator for actually like training our convolutional neural networks, and then we just send our convolutional neural network and the test set to the Google Colab TPUs, and it'll then do all the different kind of calculations on the hardware specifically designed to do matrix and vector multiplication and addition, and then it just sends the results back to us. And we also saw like how we can actually like improve the training process. So we went from having these epoch here run for 10 seconds, and then we actually like only run it like for 5 seconds down here by taking this optimization step here where we specify the steps per execution. So it's really efficient to train convolutional neural networks and just neural networks and machine learning algorithms in general on TPUs. And as already mentioned, where I'm going to do a comparison of the DPU and the TPU here when we're training convolutional neural network. So make sure to hit the subscribe button, bell notification under the video here, and also like this video here if you like the content and you want more in the future. It just really helps me and the YouTube channel out in a massive way, and I just really appreciate your support. I'm currently also doing a computer vision tutorial where we're talking about different kind of stuff in computer vision, and we're doing some different kind of computer vision project with camera calibration and stereo vision and stuff like that. So if you're interested in that tutorial, I'll link to it up here, or else I'll see you in the next video, guys. Bye for now.